For product, you are displaying up to the 98%.
98?
90 up to 98%. 98%. So for product, the method for volume average boiling point is different, and for slope is also different. In that case, you have to take the not IBP FBP. This is IBP FBP is valid for crude oil. And 50% point is valid for crude oil. Okay. Second very important thing is this. For finding out the slope, I have put over here FBP minus IBP upon 100. But you have, especially for crude oil, the recovery is up to 60 or 70%. So FBP minus IBP upon 100 is not slope. FBP minus IBP upon distilled crude, distillate recovery.
But for the product also that there was an initial boiling point and final boiling point?
No, for product you have to take the T70 minus T60 upon 60. It is written over here. This one you see. For product, you have to take for product, there are two methods. Either you take T20% data, T50% data, T80% data divided by 3, you will get the volume average boiling point, and slope is T70 minus T10 on 60. This is for product.
For the product?
Yeah.
We make analysis starting from the initial to find the boiling
point
and distillation.
And
for any product, we can do this.
Yeah. And you find out the slope and volume average boiling point. For finding out the volume average boiling point, the method is different. T20 plus T50 plus T80 divided by 3, or T10 plus 2T50 plus T90 divided by 4. You will get the volume average boiling point.
What I'm saying that if the product distilled 100% and we have the data for 100% and we have the initial boiling point and
it starts at much earlier, and the product, the cracking starts 98 or 99%. So for product, for crude oil, there was no way to clear.
But the number
A is the characterization factor, U is the method, universal oil product.
And the result was 1957?
No. This is the year. 19.
So, sir, what are the advantage and disadvantage of other base? You know that of paraffinic base. What about the intermediate and the naphthalene? The advantage
The
and disadvantage.
intermediate base is having the paraffin. This crude oil is dominated by naphthenic structures and aromatic structure. The paraffin content is less. The crude oil is better. The paraffin, because you see in KUOP, the mean average boiling point is divided by specific gravity. And if specific gravity value is lower, then your KUOP will be higher. Correct?
Yes.
Lower means lighter crude.
Lighter crude.
Lighter crude means better crude. Better yield of lighter distillates, which is required, gasoline, petrol, and diesel.
So if you are target to get the VTX, so you should select the naphthalene.
The one with higher
The 7.
Yeah, this is having
If you are
the-
target to get more of the VTX.
Yeah. Okay. And for naphthenic crude, the KUOP value is lower because density is high, and it is good for production of the new oil. So that depends on the what types of you demand, and with the help of a single test, you can predict the what types of the
final outcomes.
Products you will get and what will be. Should I go forward? No. This graph you will get. You find out if your Now, this is key fraction method, then characterization factor, then graph, then KOUP. Now, you see the significance of K. K is very specific, that it combines two characterization parameters. Boiling point and specific gravity is extensively used in physical properties of hydrocarbons and petroleum products. Wind nomogram relates molecular weight, critical pressure, annealing point, carbon-nitrogen weight ratio to boiling point and specific. This is wind nomogram. This wind nomogram is what is wind nomogram? This nomogram is like this structure. In KUOP, we add the 460 with MEBP, mean average boiling point. Here, we are adding in VABP, volume average boiling point. We add 473.7 G is the specific gravity minus 456.8. And then Muir-Blank method is this method is based on somewhere capillary is small, somewhere that capillary dia, according to the capillary dia, the constants are different. So you have to select the viscometer which should take 200 seconds to flow from in this range. If your viscosity is not in this range, then you can use this constant 4.632 for 100 degree F and 4.664 at 210 degree F, using the equation SUS is equal to kinematic viscosity in centistoke into constant B. So you will get the SUS viscosity. You can derive API, and this is graph. Suppose your API is 12, correct? And your SUS viscosity is 70. Here this is 12. Here this is 70. Where this line will touch, you note down this is the VMCI. You will get that this is VMCI. Clear?
We get what?
VMCI.
AMCR.
Bureau of Mines Correlation Index. And wipe out the base of the crude oil. Equation using volume average boiling point or mean average boiling point. In one it degree Kelvin, in another equation it is in degree Rankine. Okay. Then third method was from the this kinematic viscosity. So Muir-Blank method, and the value comes if for paraffinic base it is 15 or less than 15. For intermediate it is between 15 to 50. For naphthenic it is 50 or more. Have you heard the unit FCC?